Welcome to Building the Future, hosted by Kevin Horick. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.
Welcome back to the show. Today we have Jonah Myerberg. He's the co-founder and CTO of Desktop Metal. Jonah, welcome to the show.
Hey, thanks, Kevin. Happy to be here.
Yeah, I'm excited to have you on the show. I think, well, selfishly, I'm really fascinated by the 3D printing space and everything you guys are doing in it. But maybe before we get into that, let's get to know you a little bit better and start off with where you grew up.
Sure. So, again, my name is Jonah Myerberg. I grew up in Morgantown, West Virginia, kind of big country compared to where I am now in Boston, where we founded Desktop Metal. And Boston really is kind of the center of additive manufacturing here in the United States, which is really cool. A lot of great universities and a lot of great people, a lot of human resources here that we take advantage of. I went to school at Lehigh University and then Johns Hopkins University, studying manufacturing and engineering.
What made you passionate about that early on? Sorry to cut you off.
No, perfect. Cut me off anytime. Yeah, I mean, I was very interested in the way things worked, building things myself. I wanted to study mechanical engineering because I loved cars. I loved the complexity and the beauty of them.
Okay, interesting. So, how did you get passionate about cars then?
I don't know. Maybe it was something about the freedom of them.
Okay.
The ability to jump in and go faster and more powerful than you could alone. Machines always represented that. It was a tool to do something that you yourself, weren't capable of doing. And so I just loved mechanical, mechanisms and tools and therefore, cars and airplanes and everything kind of came naturally.
Interesting. So you get out of school, walk us through your career, because you've worked for some really well-known companies, and then let's dive into Desktop Metal.
Sure. Yep. So coming out of school, I had a lot of choices on which direction I could go, and I chose to get into hardcore engineering. I wanted to design products. And so I started working for Black & Decker making power tools, and it was an amazing experience. And then it took me to Bose up here in Boston, where I was designing speakers and amplifiers and just like products that you could use at home. And it was so much fun to either bring home prototypes and use them yourselves, or give them to your friends to have them use them and really see your designs and what you were making make a difference in other people's lives. And so that was fantastic. And then I met my co-founder Rick up here in Boston, where we started a battery company, and another incredible experience with A123 Systems, where we made a new type of lithium-ion cell that enabled anyone to really make electric battery-powered equipment that they've never been able to before. And the first was power tools. It brought me back to Black & Decker. We made lithium-ion power tools for Black & Decker, the DeWalt power line. And then we got into cars, and we got into electric vehicles.
Wow.
And so
very early on then.
Oh yeah, electric vehicles were enabled by lithium-ion batteries, and batteries very similar to the ones that we developed. And in fact, our batteries that we designed at A123 Systems are still being used in Formula One motorsport. They're some of the best batteries in the world. Yeah.
Wow, interesting. So how did you meet your co-founder? Because I think that can be really challenging.
Yes. So we met because I had previously worked for Black & Decker, and one of Rick's prospective customers at the time was Black & Decker. So Black & Decker made the three-way introduction, and then the rest is history.
Very cool. Okay. So walk us through the rest of that company and the rest of your career up until Desktop Metal.
Oh, yeah. So I worked with A123 Systems and Rick for a long time, making batteries for electric vehicles and race cars, the very pinnacle of motorsports. And then A123 Systems was sold to a large conglomerate in China, but the batteries were continued to be supplied to motorsports. I started working for some friends of mine here in Boston who were developing water treatment technology that cleaned water from fracking fields in Texas. And that was great. I mean, I have a passion for sustainability and clean tech. And so this really fit in. And so I spent a year helping them launch that company, which is doing really well right now. Then I started working for other electric vehicle companies like Renovo Motors.
Sure.
And Renovo actually was just sold to Toyota, or a business that was owned by Toyota recently. And then working for some of my customers like Mercedes-Benz and Porsche in their motorsports fields, so in Formula One and in LMP1. And that same time that I was working for Porsche and for Mercedes and for Renovo, Rick was working in venture capital, and so he was looking for opportunities that he could invest in, startups, technologies. And one thing that he discovered was that no one was really bringing metal 3D printing in the direction that he thought it should go. And that's when he approached me and said, "Hey, have you seen anyone or any companies really printing metal in a way that is accessible to small companies, to individuals, to universities?" And no, there wasn't. I mean, I was certainly a customer of 3D printing, but I was not aware of anyone printing any metal in an affordable way. And so that's when Rick and I decided, hey, we've got to go do this ourselves.
Interesting. So how did you know how to do that? Because if nobody's doing, like, that's not like a simple thing that just comes to you one day, or maybe it is because of your guys' background, or walk us through coming up with the idea for it.
Well, the funny thing is, we had about 6 ideas about how we were going to go about doing it.
Okay.
And so we started recruiting the best of the best at MIT in the materials department there, the best engineers that we could find. We started prototyping, and we started kind of vetting out quickly the different ideas and directions that we would take this metal 3D printing in this new direction. And a lot of them worked, a lot of them didn't work. And we found the ones that were kind of the best compromise in the beginning. Like, hey, we think this is a really accessible way to print metal, and we would discover it and develop it further. And sure enough, we locked onto our first product, which was the studio printer. And the really cool thing is that we have all of these other ideas that had bubbled up and been developed, but weren't quite ready yet, and we're still working on them. And so over the next few years, we're going to be releasing the next printer and the next printer and the next great technology in metal 3D printing, because we've had this time to kind of incubate them and develop them further. And it's really an exciting time.
No, very, very cool. So walk us through the process. Like, how much background do I have to operate one of these things and or design the parts that can be printed with your technology?
So the short answer to that is it is extremely easy to operate these machines, and that is a requirement.
Okay.
In order to put a printer on the market that is accessible to everyone, it needs to be easy to be driven by everyone. And so we've leveraged a lot of what has been developed in 3D printing and powder manufacturing over the past, 100 years. So powdered metallurgy is not brand new, and we leverage it in very much the same way that the powdered metal industry leverages powdered metal now, and has over the past 100 years. So the beautiful thing here about that is that there is this supply chain of powdered metal that already exists that we take advantage of. So that's kind of raw materials. That opens up hundreds of different alloys that we can print with. And then the printing process. In our studio system, we leverage FFF printing, which is the same printing process that Stratasys developed in the 80s, that Scott Crump had patented a long time ago, and that the early 3D printers were printing plastic with, and then the patents expired, and we started to leverage that same type of FFF printing, but using powdered metal instead of just polymers. And that allowed us to print green parts and then sinter them into fully dense metal parts. And then we took it a step further, and we developed the shop system and the production system, where we take the same powders that have been used for the last 100 years, and we married them with the latest inkjet technology that's been developed over just the past maybe 10, 15 years. This is very, very high frequency piezoelectric and thermal binder jetting technology. So we were able to put a number of technologies together in a way that we were able to move fast and leverage existing technologies, and then understand metallurgy, understand process development, understand machine design, and fill in the details. And the devil's with the details, and that's really, really where it counts.
Interesting. And that's smart that you leveraged obviously things from the past and current into your technologies. That's very cool. So I'm curious then, how does 3D printed metal compare to the traditional ways that some of these materials were manufactured? Is it stronger, the same? Walk us through that.
Yeah, so it's very, very similar, and it's very well validated and documented. So I think powdered metal gets a bad rap because when people think of powdered metal, they think of porous metal, and that's just not the case. Powdered metal, or I should say a part that's made from powdered metal, often starts in a porous state, but is sintered to a final, fully dense state, in which the grains of the metal grow larger than the actual particles of metal themselves. So you completely erase the history that the part was ever created by powdered metal in the first place. You drive out all of the porosity, and you end up with a microstructure that looks like it was maybe pour cast or some other traditional manufacturing method. So the properties are very similar to a casting or another, more traditional way of manufacturing a metal part.
Oh, that's really fascinating. I had no idea. That's cool. So I'm assuming then this can really help someone's supply chain, prototyping, and then their production. Is that fair to say? Or let's dive a bit deeper into that.
Yes, absolutely. So there were a number of decades in which 3D printing was new and was just being introduced, in which our customers and early adopters used it as a prototype, a means for prototyping, a means for creating models, looks like, feels like, fits like type of models. And I did the same thing at Black & Decker and Bose. We would use 3D printers all the time, but we would never expect the parts that came out of those 3D printers to hold up in torture tests, environmental or mechanical drop tests or vibration. They were a different type of material. And that was what we call Additive 1.0. And now we're in Additive 2.0 or AM 2.0, which is where the materials, the processes, the speed, the cost have all been optimized to the point where now additive manufacturing competes with traditional manufacturing in every aspect. So now it's no longer looks like, feels like, fits like, but it's functions like. It is that actual part. It's produced a different way, but it has the same properties. So this is where the industry now can say, wow, I don't need to invest in time and tooling when I want to take the jump from prototyping to mass production. I can use the same method to prototype the part as I do to mass produce it. And the beauty in that is that you're staying in that digital world longer. You have this digital development, digital validation. You can produce the parts immediately without investing in tooling, and then change the design if you want to optimize it. You have the ability to continuously improve the part without having to go back and break new tooling or waste time and money.
Interesting. Well, and it's got to be way cheaper just because you can use the same manufacturing process from prototyping to live in a consumer's hands. Is that fair to say?
That is fair to say. And what happened is that we reached this tipping point, which was basically when it became as expensive, right? And this happened a couple of years ago when the technology came forward and said, hey, we can do this at the same price without a tooling. without any tooling, we can produce your parts for the same price. And then you start to build the economies of scale, and it just runs away. Then it becomes widely adopted, more materials become available, becomes faster, and then the cost just plummets. So we're at this precipice where, hey, it's equivalent to traditional manufacturing, and then all of a sudden it's way more economical.
Interesting. Okay. So how does the design and prototyping of these actual parts work? Do I use the same software I know and have loved for years? Do I need new things? And then I guess, does it allow me more or the same creative freedoms I've always had?
Yes. So there's another area where we were able to leverage existing technology that has been around for decades, and that's Cad Cam. So CAD software, CAD software, like the pro engineers and the CATIAs and the Unigraphics, every wonderful CAD system, SolidWorks that you know and love and companies use is completely compatible with Desktop Metal's 3D printing. The files that come out of those CAD softwares are then downloaded directly into the printers and printed. It's almost like having, thinking about it, this is like a 2D environment. You want to create a JPEG or you want to create a TIFF file, and then you send it to whoever's printer, an HP printer or a Brother printer or whatever. So we do the same thing. Use whatever CAD system you want, and then you basically create these build files. These build files could be considered like the tools that are used to mass produce your parts, and they're all digital, and they're a prep file in which you arrange the parts in the way that you want them to be printed. Maybe you put different parts together or the same part multiple times. You build essentially a virtual building box of your parts that then you get sent to the printer, and then the printer just repeats, pumps them out each time.
Interesting. Okay. So does 3D printing these metals give me more flexibility in what I can do from a design side? Like, can I innovate on design and make different things that weren't traditionally available with your technology?
So absolutely. So what happens when you start talking about digital design and additive tool-free manufacturing, is that you are not constrained. Your designers are not constrained by the same manufacturing limits that are traditionally in place. And this is something that I was taught in school in manufacturing is, hey, we design a part for its application as much as for its manufacturing process. So if I want to make a bracket that hangs something on a wall, I need to first decide how I'm going to make it. And then I can determine, okay, it's going to attach to the wall, it's going to attach to something else, it has screw holes. But how am I going to make it? Am I going to make it out of a piece of sheet metal, which then I have to bend and then weld together, or whatever I have to do to manufacture it? I need to know that up front. And so I have all these design constraints that I have to work with based upon how I'm going to make it. Now with 3D printing, we take those design constraints away and we say, okay, let's focus more on the application. Instead of 50-50, we can talk about what makes this part function the best, removing material that you don't need, adding material only where you do need it, and just focusing on the function and not the manufacturing process. And so then the manufacturing process, as you print it up, is much, much less constrained. And you're able to optimize the weight, optimize the strength. And then if the part changes, or let's say if you would like to put your initials on it and someone else's initials on it, or you have a different type of application that's slightly different, but it's close enough that you can utilize most of the geometry, but you need to change a little bit. You can make custom parts very easily. Every part could be different. It doesn't matter because it's just being printed.
Very cool. So do you want to maybe give us some examples of how your customers are using your technology? Because you have some of the biggest companies and brands on the planet actually using your technology.
Oh, yes, absolutely. As a matter of fact, they are our closest, investors as well. So one of our first investors was Ford. And this is an example of a company who has wanted to get into 3D printing in manufacturing for a very long time, and who has watched aerospace like GE,
Sure.
use lasers to 3D print jet engines now for the past 20 years, and they're saying, well, shoot, we want to print cars, out of metal, but they can't afford to build these giant billion-dollar factories the way that GE did, to build jet engines. They need a more efficient, a more cost-effective way of 3D printing, and so that's what desktop metal represents, and that's why Ford was in at the beginning, and that is why Ford is now one of the first early adopters to begin to print parts for mass production for their vehicles. And there's a number of other examples like this. And certainly we work with huge companies like Stanley Black and Decker. Again, another time that I've gone back and back to my roots of the very first company that I've worked with. And these guys are innovators at Stanley. They want to grab a hold of the latest and greatest technologies and materials and integrate them into their tools. So that's another great example. And they're not the only one. We have other power tool manufacturers who are doing the same thing, like Milwaukee Power Tools. You look at other large companies like Additive, right? Additive is has shown 3D printed shoes and soles, but they're not the only ones. There are so many large companies right now looking to customize their shoes and their soles by use of 3D printing.
Interesting. So how did you and the team or advice for closing like the Fords of the world, the Additive, like you've named some huge brands here. How did you get them to actually try and your technology, and what advice do you give for people that are looking to maybe get one of these big brands to try out their product?
It's actually not that hard to connect with these big brands, because if you have something special, they're always looking.
Right.
These big brands are they're innovation leaders. They know that to stay ahead of the pack, they need to be the first adopters in these new technologies. And it's interesting. We went through this in the automotive world recently with electric vehicles. It's somewhere where Rick and I played 20 years ago, but we had we had the ability to make incredible electric vehicles, and our large OEMs were slow to adopt, and because of that, they enabled companies like Tesla to emerge. And all of a sudden, Tesla decided, hey, if you're not going to do it, we're going to do it. And they all of a sudden they're one of the most valuable car companies in the world. These large brands are not going to allow that to happen. They want to stay in the forefront of innovation and development. They don't want to enable. They don't want to not act and allow for the little guys to leapfrog them the way that kind of Tesla did to some of these other OEMs.
Interesting. So how does sustainability play into all this? And is this technology sustainable?
Oh, yes. So there's a number of, aspects of 3D printing that is, that really makes it a green technology. And one of them is just the supply chain. It's basically saying, okay, we no longer need to ship these parts all around the globe. We're going to switch to a more of a digital shipping process, in which if you have a design that needs to be produced, it can be produced locally. And just by sending the file around electronically, we can move it from one location to the other, get it closer to this destination, and then print it on demand. There is, the world is looking to reshore manufacturing, from earlier industrial revolutions, which then centralized manufacturing in countries that that could do it cheaper. We're now in the age of decentralizing manufacturing and taking especially metal parts manufacturing and producing them closer to where they're assembled. And you've seen the supply chain disruption of the last year through the COVID crisis. There are a million reasons why you want to not ship your parts globally around this world.
Sure. No, that's fair. So you guys also play in the healthcare space. Obviously, the materials you're using to print with are going to be different. but how have you leveraged what you're doing for metals into the healthcare space?
Yeah. So in fact, the metals that we're using for healthcare are not that different than
Interesting.
the metals that are metals that are traditionally used. So for almost 100 years, metal implants for dentistry have been made from cobalt chrome,
Okay.
and we use the same exact cobalt chrome materials
Oh,
in our
fascinating.
powders. Yeah, so it's something where you don't have to reinvent the wheel to get in and begin to leverage the benefits of the technology. But it's also an area where we can improve. So where cobalt chrome was used in historically because it was less expensive. It's biocompatible. It's less expensive. Um, it was easy to manufacture, but the price of cobalt has been going up significantly over the past year, to the point where it is now becoming a very expensive material to use. So we can now use the same printing process to produce titanium, where cobalt chrome was used, and
Ah,
titanium is just as it's just as biocompatible. It's in fact lighter weight, and it has the strength that's needed for dental implants and for partial dentures. In the dental industry, they would love to use titanium, but titanium was always more expensive than cobalt chrome. But now the tides are turning. So it gives us the flexibility. We're no longer stuck with one material. We have a vast variety of different materials that we can use. And dentistry is just one example of where 3D printing is used in medicine.
interesting. Can you give us some other examples of things you can 3D print in the healthcare space today, and maybe some stuff that we should be able to print within the next few years?
Yes, yeah, for sure. So any type of implant, now it doesn't have to be dental. I spoke a little bit about dental implants, but any type, hips and knees, these are all complicated implants that really should be more than just, sized, roughly on like, hey, you're a medium, or you're a large, or you're a small. These are implants that the geometry should be designed from CT scans, from X-rays, and made
Right.
extremely custom for your body. And that's the advantage of 3D printing, is you can immediately scan someone and produce an implant that fits them perfectly. So that's one great example. Another is in casts. So if you broke your arm, you can create custom casts very quickly that can go around your arm or your leg or your knee, can pop on, pop off, and they form fit to your body. And that's just, that happens, those can be printed very, very quickly. And again, just as custom to your anatomy as well. We're also developing bioplotters, and our
Okay.
bioplotter can produce, essentially biocompatible materials that include cells that can and scaffolding that the cells attach to, that can help to repair damaged tissue in your body. And one example is an eardrum repair that we
Wow.
do. You basically print a patch that goes right onto your eardrum, and you plot it out with biomaterials. And this bioplotter that we make these are just examples of applications. And there's a group called the Shaw Lab in Northwestern University who has demonstrated that ovaries could be printed, and
Wow.
they printed ovaries for mice, implanted them in mice, and the mice reproduced with those implanted ovaries. It was incredible, and that's just the
Fascinating.
beginning of where we're going with organ printing.
Interesting. No, that's wild and like really cool, right? I think it seems to me, and you can correct me if I'm wrong, we're kind of at the very beginning of all the innovation that's going to happen with 3D printing. Is that fair to say?
Absolutely. Yeah. So we're just making the tools, but the next frontier is the applications. You're exactly right. We put these out there, and then I have no idea where people are going to take them, and that's the exciting part.
Okay. Yeah, no, I agree with you. But the fascinating thing then is you must get companies or people coming to you with ideas of how to potentially use your printers in a similar space or a different space? Like, how does that work? Is it pretty easy to, was it pretty easy to go into the healthcare space? It sounds like it was, but could you use your printers in a bunch of other different spaces as well?
Yes, absolutely. And that happens more often than you think. So when we launched Desktop Metal, we had no idea how big the jewelry
Oh,
industry
interesting.
would be. We didn't even consider it. But the jewelry industry has been a huge hit in 3D printing, and it was one in which we focused on printing stainless steels or carbon steels or titaniums, or, cobalt chromes or um, very industrial materials, and we had huge brands from the jewelry industry come and approach us and say, okay, this is fantastic. We want to print gold, silver, platinum this way. Can you do that? And yes, we developed the same powdered metallurgy, the same types of inks and binders that we use on stainless steels. We made compatible with these precious metals. And then all of a sudden, these companies are producing amazingly intricate designs that they'd never been able to make before because they're printing them instead of having to, form them by hand or pour cast them.
Interesting. And then I'm also assuming that the time to actually come up with these designs and get, well, in a lot of cases, it's probably not even really a prototype. It's like you might do a revision or two, but then you basically just hand it to the customer. Is that fair to say?
Yeah. So the printers, we will develop the printers to be compatible with the metals and the chemicals that are needed to print with. The companies that are buying our printers are the ones doing their designs, and they traditionally go through this kind of cycle of, and let's take the jewelry space, for instance. The jewelry designers will come up with these designs for jewelry that they'd like to produce, and they'll take them to their manufacturing teams, and their manufacturing teams will say, ooh, that's going to be hard to make. Why don't you change this or change that, and then it'll be easier for us to manufacture. Right. So they go through a number of iterations to optimize it for manufacturing. When we present them with the printers, their designers simply upload the file and print. And there's not a lot of design revision that needs to take place. And they're the designs that come out of these printers are amazing. Stuff that I would never dream up. But these are, jewelry designers who are making them, and they can use our printers to produce these designs. It's amazing.
Interesting. So are the limits actually kind of endless, or are there some limitations on what 3D printing can't do yet? And how does a designer get notified of that?
Yes, so there are definitely constraints. There are absolutely limits to any and every manufacturing process. And I don't mean to sit here and make it sound like any and every design can be printed flawlessly right from the first start. No, for sure there is a design. There's an element of design for additive manufacturing that takes place every time, but there are less constraints. And then there's good, and then there's bad. So for instance, we're using powdered metallurgy. We're sintering it to a solid form, and you end up going from your digital design directly to your finished part in one step, which is fantastic for a number of reasons. But in traditional manufacturing, there are other ways to manufacture. I should say to prepare metals before they get manufactured. Like you can cold work them, or you can work harden them in different ways before you then go and machine them, and you end up with different properties. And so the engineers, the designers really need to know what the final properties that they want are, and then decide which way they're going to go about getting them. But there's always constraints to work around as a designer.
Yeah, that makes sense. Like somebody that doesn't have you need a bit of a background in industrial design to understand what you can and can't do, but you can push those limits once you understand what you can and can't do. Is that fair to say?
It is, and it's really a new art, and you hit on it right there. It needs to be taught in early education. It needs to be taught throughout university and into graduate degrees. Manufacturing and additive manufacturing is new now. There's all types of new design aspects that were never considered in the past. And so this new generation of mechanical engineers that's being brought up is learning all these new skills. Once you learn them and you understand them, like you said, you can do almost anything you want.
No, makes a lot of sense. So I'm curious just to dive a little bit deeper into, well, and you can correct me if I don't have the phrasing right, but so I can basically use your technology to maybe swap out or come up with new and innovative ways to design specific parts that go into, say, an automobile or some other device I'm trying to build. But how do you know, like, which parts I can 3D print, which parts I can't? Can I 3D print maybe majority of it? Or how does that kind of work?
Yeah, so 3D printing works in concert with traditional finishing processes like machining or polishing, or these kind of post-processing techniques that have been used in the metal industry, forever. So, for instance, if a part comes out of a casting, it can often have flash on it or burrs, and you use blasting or tumbling or shot peening to kind of finish that casting off and smooth it off. In 3D printing, a lot of times that's not necessary because you don't have flashing, but you can use the same type of finishing processes to polish it, to make it nice and shiny, or to cut it and machine it into a very high tolerance surface. So when we teach 3D printing, we teach it right alongside of machining. So the parts come out of the 3D printer, and then if you need them to have a very high precision hole or a very high precision surface on it, they go right into a machine, and the machine cuts that surface or drills that hole. And so now a process that would have taken 10 times as long, because the machine would have had to cut every surface on that part, now takes 1/10 of the time, because the part comes out, the geometry is already done, and you're just cutting the high precision pieces. So when you look at the components in an automobile, there are a lot that can be 3D printed, and they can be 3D printed as is, where you're just basically copying the design and putting it into the printer. But the real benefit comes when the team redesigns them for 3D printing, redesigns them for additive, takes out weight, combines multiple parts into one part.
Interesting.
There's the kind of the first order of design for additive, and that's kind of taking what you have and bringing it in. And the second and third orders, that's when it gets really, really beneficial, is when you design the parts specifically for 3D printing.
Interesting. Is there a limit to the size of something that can be 3D printed at this point?
Yeah, so definitely 3D printers are getting bigger and bigger, and we're seeing 3D printers the size of houses now, right? They're printing entire homes. We don't have metal printers that are the size of houses yet, but when you put a metal 3D printer on the end of a robot, you can print a bridge, and we see that happening all the time. There's some really, really cool innovative construction type of 3D printers out there. Now the technologies of desktop metal are getting bigger and bigger all the time as well, and we're really focused on Additive 2.0, making more and more high volume parts, bringing that cost down lower and lower. But yeah, you're absolutely right. There is a limit to the size of the part right now that you can get out of metal 3D printers.
Interesting. No, that makes a lot of sense. Very cool. So you've obviously been in the manufacturing space for a number of years in a bunch of different verticals. What advice do you give to people that are looking to get into manufacturing and or get their product manufactured?
So I guess two questions. If you are looking to get into manufacturing, then obviously you need to be up to speed with all of the latest and greatest manufacturing tools out there. Right. So if you want to make some sort of metal component, what are the technologies that you can use to make that? And right now, it includes a number of different, additive tools as well. If you're a manufacturer and you're looking to manufacture your component, you can look one of two different ways, or you can do it in-house, or you can find a supplier that can do it for you. And this is really, it's interesting. You have these big OEMs that I mentioned before, like Ford and BMW, and these companies. The first thing that they did is they brought in this technology in-house, and they said, we want to learn about it. We want to learn what we need to do to design parts for 3D printing, how much it costs to 3D print them, what are their limitations, and really learn. And they did that not because in the end of the day they were going to make their own parts, but they did that because at the end of the day they were going to take this technology to their tier one suppliers, to take this to their suppliers and say, hey, we want you to make this part for us. We want you to make, 1 million of these parts. So we want, buy these Desktop Metal machines and start producing these parts. And now we know how to design for that machine. So they became the expert, but they pushed the manufacturing on somebody else.
Okay. Do you guys manufacture anything, or you have partners that handle that?
So we print parts all the time, all day long.
Okay.
We're making thousands and thousands of parts, but not for sale, not commercially, more for, testing the machines, samples for customers, both internal and external samples. We just love to develop and refine our processes, our machines, our metals. But we have customers who are the ones buying our machines, and then they're the ones who print for hire. They're the ones, if you called me and said, hey, I need 100 of these parts, I'd say, absolutely. Let me introduce you to Joe's garage down the street who bought a 3D printer from us, and they can make them for you. And that's how we kind of, share the connections and share the business and grow organically.
No, that makes a lot of sense. So I'm curious, we're kind of coming to the end of the show. So is there any other thoughts or advice that you would give to entrepreneurs out there? Because you've obviously worked at some big brands, you've landed some big brands, and you've done your own companies. Is there anything that you would pass on to younger generations? Oh,
do not be afraid to fail. Get out there with your good ideas and give it a shot and show everybody what you're doing. Their innovation is, what drives all of our industries. And I think when you start to, it can be intimidating to think about working with these big brands at first. But what you find out is that they just want to work with good people. They just want to work with smart, people who get the job done. So work, quickly. Don't be afraid to fail fast. And you will attract really great partners while you do it.
Very cool. I think that's really good advice. But Jonah, we're coming to the end of the show. So how about we mention where people can get more information about you guys and any other links you want to mention?
Oh, yes. Come visit us at desktopmetal.com. You see all of the really cool things that we're developing here in 3D printing of metals, polymers. Now we're 3D printing wood. It's really an amazing time to be working in 3D printing, and especially to be a designer and having these new 3D printers at your disposal to manufacture your designs.
Totally makes a lot of sense. Well, Jonah, I really appreciate you taking the time out of your day to be on the show, and I look forward to keeping in touch with you, and have a good rest of your day.
Thanks, Kevin. You too.
Thank you. Okay, bye.
Thanks for listening. Please visit our website at buildingthefutureshow.com to join the free community, sign up for our newsletter, or to sponsor the show. The music is done by Electric Mantra. You can check him out at electricmantra.com and keep building the future.